This is the first of several videos on molecular geometry. On this one, we will eventually concentrate on what is called electron domain geometry. In previous lectures, we drew Lewis structures. But the Lewis structures, as we drew them, are two-dimensional structures. In real life, molecules have a three-dimensional structure. This is called molecular geometry, and molecular geometry is always relative to the central atom. And it does require a lot of memorization. It's all based on what is called VSEPR theory. VSEPR stands for valence shell electron pair repulsion. What does this mean in simpler terms? The lowest energy shape for molecule is when repulsion between pairs of electrons is minimal. This, of course, is based on Coulomb's law because we know repulsion is related to the distance between electron pairs. When the electron pair distances are as great as they can be, the repulsion will be as low as can be. Let's take a look at methane, CH4. When we draw the Lewis structure, it looks like this, and it appears that the angle between the carbon-hydrogen bonds is 90 degrees. But that's a two-dimensional structure. In real life, methane has a three-dimensional structure where the angle between the bonds is just a titch over 109 degrees. Now it turns out that we're going to be discussing two types of geometry. First is called electron domain geometry, or EDG. The second is the molecular geometry, and this is derived from the electron domain geometry. So the remainder of this video is going to be on electron domain geometry. So the first thing that we need to do is define what an electron domain is. And it is, once again, always based on the central atom of the Lewis structure. An electron domain is an unbonded pair of electrons or any type of bond. And it's important to realize that a single bond is equal to one electron domain. A double bond is equal to one electron domain. And a triple bond is one electron domain. So any type of bond, single, double, or triple, between two elements is one electron domain. And we talk about bonded versus non-bonded domains. So let's take a look at the methane here. Here we can see that there are four bonds, one between each hydrogen and carbon. There are no unbonded pairs around the central atom. So here we would say that there are four electron domains, and they are all a bonded domain. How about ammonia? Here we can see that there are three bonds between the hydrogen and the nitrogens, and around the central atom, an unbonded pair. We would say that there are four electron domains here. Three are bonded, one is non-bonded. Formaldehyde, there's a bond between the hydrogen and carbon, another bond between a hydrogen and carbon, and a double bond between the carbon and oxygen, but that counts as one domain. The unbonded pairs around the oxygen don't matter because it's not the central atom. And we would say here that there are three electron domains, and they're all bonded. Here is iodine pentafluoride. We can see that there are 5 bonds and one unbonded pair around the iodine. So that would be 6 electron domains around the iodine, 5 bonded, 1 non-bonded. So those are examples of electron domains. Now it turns out that there are 5 electron domain geometries. You can have 2 electron domains. That will look like this. That's the central atom. These are the electron domains. And they are linear. It's 180 degrees. You can have 3 electron domains. That looks like this. It's called trigonal planar, and the angle between the domains is 120 degrees. At 4 electron domains, we get off the 2D plane, and we now have a 3D construct that is called tetrahedral, and the angle between the electron domains is 109 degrees. 5 electron domains is what is called trigonal bipyramidal, and the angles are 120 degrees on this plane and then 90 degrees on the axials. And 6 electron domains is what is called octahedral, and there is a 90-degree angle between all of the bonds. Those are important to memorize because, as we'll see in the next video, molecular geometry is derived from the electron domain geometry. And I can't emphasize it enough, you must memorize the electron domain shapes and angle values. It's a very popular question on the AP test. So that does it for electron domain geometry. To review, there are two types of geometry. The first is called electron domain geometry. The second is called molecular geometry, and both geometries are based around the central atom. There are two types of electron domains. There's the non-bonded pair or any type of bond. Single bond, double bond, or triple bond, each counts as one electron domain. There are 5 electron domain geometries. So to look at it in table form, 2 electron domains is linear, and the domain angle is 180 degrees. 3 is trigonal planar at 120 degrees between domains. 4 is tetrahedral, 109 degrees between domains. 5 electron domains is trigonal bipyramidal, and that gets you 120 degrees and 90 degrees. And 6 electron domains is called octahedral, and that is 90 degrees between the domains. In the next video, molecular geometry will be discussed, and we'll see that it is derived from electron domain geometry, and you're going to have to memorize this. So obviously, the next video will be on molecular geometry, and then from that, we can go with function follows form, and we'll begin to be able to discuss things like bond polarity, molecular polarity, and intramolecular forces.